Welcome to qnawire.
So for this problem, we use the distributive property, which is given by equation 11.4c, and we use this to obtain 9 single term cross products. So A cross B will be equal to, let's write the vector A first. So AX, AY, and AC are the components of A in X, Y, and Z directions. Similarly, we will do the same for B vector. Now we apply the distributive property. So here I am just taking cross product of each term or each component of X with each component of Y. And so on. And the last term will be this cross product with this. Now each of these cross products of unit vectors can be evaluated using the results of problem 21 and equation 11.4b. So basically we will use the cyclic rule to find the cross product of these terms. So it goes like this: I cross j is k cap, j cross k is I cap, and k cross I is j cap. And the rest of the cross products will be 0, which means that I cap cross I cap will be 0, k cap cross k cap will be 0, and j cap cross j cap will be 0. Now we apply this rule and we get A cross B to be AXBY k cap, which comes from here, plus minus of AXBZ j cap, which comes from this term, which is I cap cross k cap is minus j cap. So basically, if you go like this is the rule we follow, and if we are going anti-clockwise, which means j cap cross I cap will be negative k cap, k cap cross j cap will be negative I cap, and I cap cross k cap will be negative j cap. So this is the rule that we used here. So I cap cross k cap will be negative j cap. So let's write all the terms. Now we can simplify this expression a little bit. So we get A cross P to be equal to AYBZ minus AZBY. This is the I component. This will be the jth component of A cross P. And lastly, we have the kth component. And this is exactly the expression that we are asked to prove. Now for part B, so the rules for evaluating a literal determinant of a 3 cross 3 matrix are as follows. So the indexes on the matrix elements identify the row and column of the element respectively. So if you have a matrix like this, so this means that let's take A23. So A23 represents the element at the second row and third column. So second row is 2 and third column for which we get a 3 here. And the determinant of this will be equal to plus A13 times A21, A32 minus A22, A31. Now we applied this pattern to evaluate A cross B using the determinant rule. So we know that A cross B is equal to determinant of this matrix where I, J, K are the unit vectors and AX, AY, AZ are the components of A, which is the first vector um, in the direction of the unit vectors, and the same for B vector. And we evaluate this determinant using this expression right here. So we get the value to be and you see that this expression is exactly the same to what we found in part A here.